Alrighty, so here is the assignment solution for the first assignment. I literally just recorded the whole video with my mic with no power. So I've just solved it. It's fresh in my head. So I've got to re-record it. Hopefully I can try and forget everything I just done. I try to throw away the solutions and not think about them for a while before I implement it. So it's a new experience for me. As I said before in class, if you look at this and go, oh, there's no way I could have coded that or whatever, I don't expect you to. Your students. I've literally wrote this assignment basically 3 times every year for the past 20 some odd years. I've never, it's not the same assignment, but I've written substantially similar assignments before. They're all solved the same basic way. So don't panic if you didn't do it the way I did it or anything like that. That's why I show you this, so that you can learn from it. So the simplest way to get started is to just look at things that are red and make classes for them. And not think about it too hard. Okay, so it's saying that computer player can't be applied to the given types. So I need a constructor in computer player that takes a string, and I'm going to make some mistakes on purpose. I'm going to do the simplest thing that works, and we'll see how I improve it going on. So if you're yelling at your screen going, that's not the way to do it, you're right, it's not. But that's okay for now. So computer player has a constructor. It takes a string, and if I look at this, it's going to take a smallest number guesser. I'm going to throw an illegal state exception, just saying not implemented yet. That way, when I go to call it, it'll crash. I'm going to take one for the largest and one for the best. And all I'm trying to do right now is get things to compile. I don't care if they're correct or not. I just want it to be in the ballpark. So it says computer player, that this can't be converted to a player. So computer players have to be a subclass of player. And best number guesser is abstract. Did I actually make something abstract? I have no idea whether that's interface should be class. I think I just made a mistake with what I chose to do. I'm not even sure what an app interface is. There must be a play method that takes 3 integers and an array of players and returns a winner, which is a player. to grab that not implemented yet thing. Rebuild, see where we're at. And I can't find the get name in player. And I don't know what get name is supposed to return. Let's take a look at what it's complaining about. Get name is on player and it returns a winner name, and that is of type string. So that's cool, but it can't find this thing called a number guesser, so we'll add that. Notice I'm not even looking to see what kind of thing, what context it's used in or anything. I'm just making a class. We'll fix it later. And it can't find a guess that takes an int and an int. Oh, and these are min and max. Okay, so it takes a min and a max. There we go. And again, throw the exception. And it can't find in smallest number guesser, it can't find guess that takes 2 ints and returns an int. Okay. And I'm going to shortcut it. I'm going to tell you the exact same thing's going to happen for best and largest. So if I were to continue compiling, it would tell me the same thing about these two. So we'll just shortcut it. And smallest number guesser can't be converted into a number guesser. That means that, and I say go to, so for me it's Command B. We'll see that that takes a number guesser. So smallest number guesser must extends number guesser. And largest is going to have to do the same. And best is going to have to do the same. And we have a problem with all of them. These return ints. Number guesser returns void. The problem was when we looked at the number guesser test, we don't know what this returns. No idea. And you can't override a method based on the return type alone. So that means that the number guesser actually takes an int. We just didn't know that at the time based on the context. No suitable constructor found for a computer player. It has to take a name and a number guesser, and we only have it taking the particular kinds of number guessers, so we'll go ahead and add that too. And you need something in the player one. Player one is a computer player, and it needs a take turn method. So player one needs a take turn method that takes 2 values and returns an int. And again, we're going to throw the exception. I just throw the exception to make sure that I don't, that I'm really clear that when it fails, it's because I haven't implemented something. And the I'm not entirely sure why I'm getting that warning message, but it's in the tests, so I don't think it's anything I'm doing. So there we go. If I go to run the tests, just to make sure, and I'll just click on here and say run all tests. They all fail, but that's good. I've got it compiling. I don't have anything blowing up in the tests except that they're all failing, so that's good. Now's a good time to take a break. I'm not going to take a break personally, but this is when I would suggest students go off and take a break. Then I'm going to look at the tests and see what's the simplest thing to implement. It turns out that the smallest, largest, or best are going to be simplest. So look at the smallest. We can start with a bad one. So two schools of thought. You can start with all the error checking first, or you can do the error checking last. I like to start with error checking first. So the problem is that we're passing in 1 and 0. So this is the same as saying, and min is 1 and max is 0. So this is the same as saying, pick a number between 1 and 0 where 1 is the largest. Pick a number between 1 and 0 where 1 is the smallest and 0 is the largest. You would look at me very strange if I asked you that. So that's why we're throwing this exception. So in our smallest number guesser, we need to say, if A is greater than B, throw new, and I know what it is, but let's go take a look. It should be throwing a legal argument exception. So we're calling min and max, so I can now change these to min and max since they have proper names now. And then the string format just replaces the %ds with the parameters I pass in, min and max. And this has to now become min and max. So let's run the test. So the bad guess works, but the guess does not. So let's take a look at what the guess is supposed to do. So when we guess between 0 and 1,000, we return 0. 1 and 1,000, we return 1. 99 and 1,000, we return 99. So we always return the minimum. So we can go to this throws and actually say that we're going to return min. And again, run the test. Now I can look at the largest test, and this time it's always picking the largest one, and it has the same kind of thing for the bad guess. So we're going to take the smallest guesser and we're going to take it and make it the best guesser, or the largest guesser. And we'll have it return max, and we'll run its test. And best guesser, if you're picking between 1 and 1, it returns 1, so it's either returning the smallest or the largest. 1 and 2, it returns 1, so it's returning the smallest. Between 1 and 3, it returns 2, so it's not returning the largest or the smallest. 1 and 5 is returning 3. 3 is midway between 1 and 5, right? 1 and 2 on one side, 5 and 4 on the other side, 3 is left in the middle. 1 and 7 returns 4. 1, 2, 3, 7, 6, 5, 4 is left in the middle. So how do we get 4? Well, we take 7 plus 1 and divide it by 2, and that gives us 4. 5 plus 1 is 6, divided by 2 is 3. 3 plus 1 is 4, divided by 2 is 2. 2 plus 1 is 3, divided by 2 is 1.5, which equals 1, and because I know Java, the 1.5 gets rounded down to 1, gets truncated. The best guesser, very similar to the largest. And the smallest, we'll take this. the min plus the max divided by 2. Run those tests. They should pass. Run all the tests again, just see where we're at. So these 3 pass. The one thing I don't like, though, is that I've got this chunk of code here, and here, and here. I don't want to put them all there. I want to actually go to the number guesser and put them up there. So the number guesser is a good place to use the, actually we'll get to that in a second. I'll just put it here and we'll return 0 because I don't know what else to return. So we'll run the test. We'll see that they don't work. The bad guesser ones don't work, right? The reason why is that I'm no longer calling this code anymore. It's quite simple to call it. I just have to say super.guess min-max. This is not a good fix. I want to be clear. I will give you a better fix, but this will work. Right? So the super.guess is calling the parent's guess thing, and now they're all working again. Yay! I don't want to do that. One thing I might forget to call it. And when I might forget to call something, that's a really good time to use the template method design pattern. So the template method design pattern is really simple. We make this one final. Absolutely drop dead simple. And we add another method that's exactly the same. We mark it as protected. And we call it doGuess. You don't have to call it doGuess. You can call it whatever you want. And it's not final, it's abstract. Which means that you don't need final for the parameters on an abstract method because there's no code to change them. And you can't have an abstract class if the class is not abstract. So now we return, we'll do final int guess, or retval. So the patterns are almost always rote. You just, this is the way you implement it. It's no thinking involved, right? I do my common bit of work. Could come before, could come after, could come before and after. And then I call my method. And I could have several abstract methods that I call. I think I've done something one time where I had like 5 different abstract methods. So you can do some work, do some abstract method calls, do some more work, do some more abstract method calls, your choice. It's even possible that these methods aren't abstract and they just have a default behavior. In this case, it makes perfect sense to have no default and only abstract behavior. So now we've got that working, but it won't compile anymore because this is a final method and we're trying to override a final method. That's because we didn't update it. This should be protected. Int doGuess. And we'll do that for best and largest and smallest. And again, that's just a template method. If you don't remember how the template method works, there's a video. Nope, I didn't mean to run, running the test. So all the tests work still. There we go. Another thing I've noticed though, when I did that, is I've made an abstract class, but I didn't make an interface. So I'm actually going to rename this. And I don't have to do this step. I can choose to. I don't want to touch the tests. Okay? Do not touch the tests at all. So hopefully this does not change the tests. No, it did. So that's bad. So I'd want to make sure that I go back and copy my tests over, but that's just an unfortunate thing. So I'm going to make the new interface called number guesser, which is an interface. I'm going to give it this method in the number guesser. And I'm going to have the abstract number guesser implement it. And run all my tests again. Right, so that's a polymorphism design pattern-esque thing. Right, so that's cool. I've got my hierarchy fixed up. I've got the test passing, all that. Time for another break. That's what I would go and do. So the next one is a computer player test. Again, we'll start with the bad thing. So the bad constructor, it's pretty simple here. We can see that the name can't be null, the name can't be blank, and the guesser can't be null. So I can easily go through the computer player. And I'm gonna make this as painful as possible. So it turns out that name has an isBlank method, the string class. So there we go. And I'm going to do this. And do this. And do this. And do this. Oh, I shouldn't have put that to take turn. That was a mistake. So the bad constructor is working. Awesome. What don't we like about this? Well, we don't like the fact that that same code is repeated multiple times. So I'm actually going to just call this, right? Do the constructor chaining. Now this is also not going to work, but that's okay. We'll fix it. Right, but if I can defer it all to one constructor, I'm happy. The problem is that this is a recursive call. This computer player constructor is calling that computer player constructor. I'm going to call that one. So I want to call the number guesser one, which means I'm going to have to cast it. Now again, still wrong. So don't be thinking this is a good way to do things. It's not. Right? So they're all going to look like this. And if they're all going to look like that, and they're all just calling the number guesser one, and they're all subclasses of number guesser, and they must be because we're casting them, we can get rid of them all. Okay? Don't need them. Right? They're all just number guesser. Right? And I can run the tests again. It'll compile, so if we've made a mistake with compiling, it wouldn't compile. And we're still passing constructor, so we're awesome. So the make largest guess or make smallest guess, doesn't really matter, is not implemented yet. First off, we're crashing on the get name. So let's go to computer player and deal with the get name. So computer player doesn't have a get name. Default make all my variables private and final. And I guess I need to do the same for number guesser, makes sense. So I'll try that, see where we get to now. So we made it past the get name, so get name works. Now the problem is that we are not actually making use of the guessing. So this is the smallest number guesser, and we're doing from 0 to 100. So 0 to 100, we're guessing 0. Then it becomes 1 to 100, so we're returning the smallest guess. And we've got a smallest guesser for that, so we can just very easily do this. So it takes a min and max, so I'm always looking for opportunities to make my parameters have more meaningful names. So that I know that they're passing min and max, I will change it to that. Another way you might have implemented this, and I really hope you did not, is if you somehow did something to say if the number guesser is a smallest, then return the min. If it's largest, return the max. Otherwise, return the math. Right? If you were trying to figure out what kind of guesser you were dealing with in here, don't do that. This is what polymorphism is for. So run all the tests, see where we're at, and cool. The computer player tests pass. So now we're left with the number guessing game. So again, we've done some work. Time to take a break. I won't be taking a break. We've got bad play, so again, I'm going to deal with the exceptions first. There are four issues. The min could be greater than the max, right? I'm asking you to pick a number between 100 and 99, where 100 is the smallest and 99 is the largest. Makes no sense. The number to guess is outside of the range. If I ask you to pick a number between 1 and 10 and I guess negative 100, or the number to guess is actually negative 100, you will not enjoy that game, right? And the number is too large, right? But pick a number between 1 and 100 and it's 200. You won't be happy. And then issues with the players, right? Some of the players are null. There are no players, that kind of thing. So let's start with this one. That. So we're going to go to our number guessing game. Number guessing game and the number guessing game test. So here we also learned some variable names, min, max, and number to guess, and players. So we can name these better. This is min, this is max, and I like to line these up. Number to guess. Like to line them up because it just makes it easier to read if you have a bunch of parameters. And line them up, much easier to read. Right, so if the min is greater than the max, and back to the string.format, just a nicer way than doing the plus and all that. You can read it. Min number must be less than max number. And actually that message is strictly speaking wrong, but that's my mistake. That should have been less than or equal to. And if the number to guess is less than the min, or the number to guess is greater than the max, so let's try that and just see where we're at. Oh, did I put in the wrong values in my... Oops. No, not oops. Min max, min max, min max. Why am I not understanding what went wrong? Oh, that's not min and max, this is number to guess. And this is max, and this one is number to guess and min. One thing to pay attention to, I am doing very little work at any given time. I do some work, I test it, I do some work, I test it, I do some work, I test it. Okay? I'm very productive that way. And we're expecting an illegal argument exception, but we're getting a legal state. That simply means in this case that we've gotten further along in our code, right? We've dealt with these error conditions, we haven't dealt with this one. So the players can't be null or empty, so we'll deal with that. So checking to see if an array is null is really simple. If the players equals null, that can be null. Checking if it's empty is also really simple. You have to have at least one player to play, right? And we're still getting that illegal state, but again, it simply means we've gone further, right? We've dealt with those two, we haven't dealt with this one. This means we have to actually loop through. And the messages we get actually record the index, so we're going to need to use the for loop that lets us have the values. And then if the player at that position is null, right, so if player 0, 1, 2, 3, 4, whatever is null, then it print out it can't be null. So let's give this a try again. And we shouldn't be getting to not implemented yet. Actually, we should be. The bad play is working, right? We have no trouble with the bad play. All the errors are caught. So now it's just making the game work. Again, that was a substantial chunk of work to get this working. So now's a good time for a break. Good time for a break. And we'll just do the last thing. So, well, we'll keep this as throw. So we're going to want to, at a minimum, loop through all the players. And we're going to want to tell each player to take their turn. Problem. Computer player has a take turn, but player doesn't have a take turn. So what we actually want to do is go to computer player and add a take turn. Also, interestingly, this get name is not implemented. This kind of tells me, it's a big hint, along with the fact that, computer player, I can have a human player, I can have a network player. They all take turns in a different way, right? The computer player has to type in a number, select a number from a UI. A network player has to read it from the network. A computer player has that guesser. So the take turn method works completely different for each one. That kind of means polymorphism, and it needs to be abstract. So I'm going to do what I would normally do, which is make an interface right at the top of my hierarchy. I have no reason not to. It seems like the kind of thing where I could have those abstract methods and all that. So we'll just make those like that. Now there's a get name and a take turn for all of them. And because I've added the interface, I'm going to also add my abstract player. It's an abstract class, and it implements the player. And I'm going to go to computer player. I'm going to see, is there some stuff that makes sense in computer player that I could move up? Well, every single player, doesn't matter what kind of player, a network, a computer, a human, they're all going to have names. So I'm going to take that name thing and I'm going to move it up into the abstract class. And that means I'm going to have some of this constructor. And because it's an abstract class, I'm going to make it a protected constructor. No reason for it to be anything other than protected. And I'm going to set the name in there. And I don't have a number guesser because humans don't have a number guesser. They are the number guesser. Right? Network player, we don't know what it is. Is it a human or a computer on the other side? We don't know. That means here we have to call super, passing in the name, and we don't need to do the validation because it's being done up in the parent. And we don't have the name anymore because we moved that variable, and we don't have the ability to access that, and getting the name is going to be the same for all of them, so we'll put it up here. So I'd like to be able to move code up in the hierarchy. So now computer player deals with just the number guesser and how they take their turn. It doesn't have to deal with all of the stuff that's common to all of the players. Right? A human player, totally different. A network player, totally different. But they all have the name. They all have to validate the name the same way. They all have to be able to get the name. So vector number guessing game, it can now call take turn. That will now be polymorphic, and we pass in the min and the max. Okay, so I told you a few things about the game, right? So let's say we have 3 players, the smallest, the largest, and the best. I say pick a number between 1 and 100. The smallest is going to guess 1. The next player is going to be told, okay, pick a number between 2 and 100. They're going to guess 100. The next player is going to be told pick a number between 2 and 99, right? Because when I guess 1, the new minimum has to change to 2. And when I guess 100, the new maximum has to become 99. And it keeps going that way until somebody guesses it right. So this isn't going to work. I need to be able to change my min. I need to be able to change my max. In order to do that, I need variables that can change. The min and max that are in the parameters are final, and I always want my parameters to be final. So I make temporary variables if I want to change them. And I always declare all my variables up at the top of the scope. The scope is anytime we have these squiggly braces. So now when I pass in the current min and the current max, and I want to get their guess, right? What did the player guess? So I take the turn, that gets me their guess between the current min and the current max. There's 3 possibilities. If the guess is less than the number to guess, we do something. Else, if the guess is greater than the number to guess, we do something. Otherwise, they were the same, and we set the winner equal to the player. Okay, so winner, we don't have a variable for winner. We'll just make one. And I actually want to keep looping through all the players. Right now, each player only gets one turn, but I want everyone to keep guessing as many times as they need to until somebody gets the win. Somebody guesses a number. So I'm going to say, well, true. I'll fix this code up later. I do not like well, true. But I will show you. So I'm going to return the winner. This is horrible. I don't like it. Once we do that return, it says we don't need to have this. Okay? What I want is the return statement to be the last thing, but we'll come back to that. So this will work. So if the guess is less than the number to guess, what we're going to say is that pick a number between 1 and 100. I pick 1. Well, the number to guess is 20. So 1 is less than 20. So we're going to say that the current minimum is assigned their guess plus 1. Otherwise, the current maximum is assigned the guess minus 1. Let's see if this works. It does. We're done. We can hand in the assignment. Yay! One change. I don't like the returning the winner. It's very simple. All I have to do is say break here. And break, when we do that, stops executing this for loop. And we just have to change this to well, the winner is equal to null. So while we don't have a winner, let everyone take a turn. Right? And once we get a winner, we stop. We just have to return the winner. Passes all the tests. So what I want you to take a look at is, we're just going to go through all the classes really quick. This is error checking. Those are error checking. Just code, error checking. Code, that's the thing I provided. Some actual logic with a bunch of error checking. That and that. So the only actual if statements that are of consequence that are not error checking are these ones here. Right? This is the whole logic of the game right here. Everything else is just straightforward assignments, really. There's no real if statements involved. I'm not checking to see is this a computer player. I don't care if it's a min or a max, smallest or largest number guesser. It doesn't matter. Nothing. If I want to add a new number guesser, the computer player won't be impacted. It'll just take a number guesser. It'll use that number guesser's guess thing. If I have a different kind of player, then the number guessing game will just ask that player to take their turn. And it doesn't know what kind of player it is. It doesn't matter. If it's a person, it'll wait until they've typed in the number or they've selected it with a GUI or whatever. If it's a network player, they'll just sit there and wait until the player on the other side of the network takes their turn. If it's a computer player, it'll do whatever the computer player wants. It doesn't know or care what it's dealing with, right? That's the important bit. If we ran this program, it's not very interesting. So I'm going to add one more piece to make this an actual game that we could actually play. And that would be, before they take the game, I guess, I'm going to do system.printf. And now we run it, and we'll see. That's not very interesting without the %n. Try to run that one more time. Okay. So we see the smallest player went first. They picked 1. So now the next number can be 2 and 100. The next player was the largest one. So now it's pick a player between numbers between 2 and 99. And then it's the best player goes. So it's between 2 and 49. And keeps going up until they get 47. It's a boring game because it'll be the same every single time. And of course it's boring because it's all computers. We're not going to make a human player right now. But in our main, we could actually do this. Use a random number. So next int, we'll return a number between 0 and 99. So we just have to add 1 to that, and it'll become a number between 1 and 100. Now we can run the game. And apparently the number was 77, I guess. 45. Right. So we could even go a little step further in our number guessing game and say we can get the player.getName. Oops. This should be %D. No, it should have been player get name. Now I'm going to show you 2 things. So remember, I don't like doing this, and see, I've done it in 2 places now. So I've had to go get name in 2 places, and I don't like to do that. So final string player name. And I like to order my variables in the way that they're initialized. And now I can just call player name. Don't need to call the same method more than once if I don't have to. Right, so now we can see what people are guessing and all that, whose turn it is and everything. So it's easy to, now that we've got the game basically working, we can start adding things out. We could say, we could even do so we can do that. And we got a much more interesting game, right? So 1 is too low, pick a number between 2 and 100. 100 is too high, pick a number between 2 and 99. Right? 50 is too high, so now it's going to be between 2 and 49. Right? We're going to guess 2 again, that's between 3 and 49. We're going to guess 49, it's between 3 and 48. Right? Keep going, keep going, keep going. 5, right? So the number to guess was 5. So easy to make our game look better and be a much more interesting game. There you go.